water is a very important part of soil. The amount of water that is available in soil is extremely important in how well plants growing in that soil are able to survive. The water that is available in soil is present within pore spaces. And when you think about soil, soil goes down to the water table, but how does it stay within the top layer of soil where plants can get at it is because there are pore spaces, millions of little glasses under your feet. That's how water stays in soil, and that plants are continuing to be able to get water. The amount of water that's available is important, and that's why it's so important that soil has the capacity to hold on to water for a while. The longer time that it can hold on to water after it rains, the longer there will be water available to plants. Now, this has positive and negative impacts, because if you're in a very wet environment where you get a lot of rain, the fact that your soil is always holding on to all this water for a long time and not letting it go down to the water table means that you're probably going to have a lot of flooding, because where else is the water going to go? If it can't go into the soil because all the pore spaces are full, it has to flow downstream, and that creates floods. So it's important that we understand our soil's water holding capacity. And in our lab, we use a variety of different measures to measure some of this information about how our soil is interacting with water. We can test soil moisture content. That is the percentage of a mass of soil that is water. There's a couple ways that we do that. We may do that by an oven drying method, where we will first weigh soil that we've got right from the field before it's had a chance to dry at all. Then we'll dry it completely in an oven of over 100 degrees C. So we know that all the water is going to vaporize. And then we weigh it again, and the difference is how much water it contained to begin with, and we can determine what percentage of the mass was water. Similarly, there are sensors available that can measure percentage of water that is in the soil around them. Another thing that we sometimes do is not to measure the moisture content of the soil. We may measure things like the infiltration potential of the soil. There are different tests for infiltration as well. One of them is to test how long it takes for a set volume to infiltrate over a known area. And to measure that, we may take a ring of a known surface area, put that down into the soil, and then you pour the water in and you time it. And that will tell you how quickly that volume of water is going to go down. If it takes a longer time to go down, then the water theoretically would be sitting on the surface for a while. But in reality, without the ring there, it's probably moving. If it doesn't percolate immediately, doesn't get caught up by stuff on the surface, sticks and leaves and that sort of thing, it will start moving very fast. So a quick infiltration is important for reducing runoff. You might also measure how much water can be infiltrated in a certain period. And that you may take a very large volume of water and put it through a sprinkle can so it distributes fairly evenly over a known surface area, and then give it a certain time and see how much it's going to infiltrate. So those are some of the things that we explore relative to the relationships between soil and water here at the Schmidt Lab when we work with soil samples. And that's all for now. Tune in again next time for more Turd Nerd updates.